right, good. So today basically we'll be looking at how to use the product and the quotient rule. So welcome back to your favorite inorganic tutor YouTube channel. So today we'll be looking at the quotient and the product rule. All right, how to use the quotient and the product rule to differentiate. All right, so now let's take this question. Y equals 10 power 1 minus x over 1 plus x. Right. So this question, we have to differentiate this function. We have to differentiate this function. So how do we differentiate this function? Right. So having this exponential function, we have to take the natural log on both sides. We have to take the natural log on both sides. All right. So we introduce the natural log on both sides. So we have ln y is equal to ln 10 power 1 minus x over 1 plus x. Good. So after you finish introducing the ln to the both sides of the equation, you now bring the exponent, right? You bring the exponent down, right? So that we have ln y is equal to, bringing this exponent down, we have 1 minus x over 1 plus x, then ln 10, right? This applies over here when you have log a power b. You know that this is the same as b log a, right? So the natural log is just a log of free states of base z, right? But it's the same logarithm that we are applying. So we apply the law of logarithm over here. When you have a log, exponential log, you bring the exponent back, right? So that's what we have here. So we are applying the same law on this function, right? So now we have this function. This is what we have now. So how do we differentiate this function on the left? You know that when you want to differentiate ln y, you differentiate the function inside, right? And then you take 1 over the function, right? So we have 1 over y times differential of the function, which is the y, right? So that's how we operate the ln. Good. It's equal to this side of the function. We have to use what we call the quotient rule. All right. So within this function, we are applying the logarithm law. We are applying the exponential, which is the logarithm law, and we are going to use what we call the quotient rule to solve this problem. All right. And what does the quotient rule says? It says that when you have a function dividing a function, what you do is that you first differentiate the first function, right, which is the u that we also always talk about, right? And then you maintain the second function. So let's say the u is equal to 1 minus x, and then the v is equal to 1 plus x, right? Always the u is the numerator and then the v is the denominator. Good. So the quotient rule says that we differentiate the first function and then maintain the second function, right? And then minus, we differentiate the second function, then we maintain the first function, all divided by the square of the second function. So this is how the formula goes. Differential of the first function with respect to x, then we maintain the second function, which is this, the v, minus differential of the second function, then we maintain the first function, which is the u, with respect to x, right? Then we divide by the square of the second function, which is the v, right? So that is the quotient rule. So now let's apply the same idea on this question, right? So here our u is 1 minus x. So we differentiate 1 minus x, then we maintain 1 plus x, right? So let's maintain 1 plus x. Then we differentiate 1 minus x with respect to x, right? We maintain the second function, then we differentiate 1 minus x with respect to x. Then minus, we maintain the first function, right? Then we differentiate the second function with respect to x, right? All divided by the second function squared. The second function squared. And don't forget that we have a constant, which is the ln 10 over here. So all multiplied by ln 10. All multiplied by ln 10. Alright, so we have, this will be y prime over y is equal to 1 plus x, and then differential of 1 minus x is minus 1, right? You know that when you differentiate 1, you get 0, and then when you differentiate minus x, you get minus 1, right? Good. Minus this will maintain, and then differential of 1 plus x is 1, right? All over 1 plus x all squared. Don't forget your constant, the ln 10. Good. So from here, y prime over y is equal to, when you expand this bracket, you have minus 1 times minus 1 minus 1 times, then we have minus 1 plus minus 1 times x, which is minus x, right? And then this expands this bracket as well. We have minus 1 plus x, and then minus 1 times 1, which is that, right? So plus x all squared, then our ln 10, right? So here, let me continue here. Here, y prime over y is equal to, you know that this will take off this. So we have minus 2 over 1 plus x all squared multiplied by ln 10, right? The x, positive x, will take care of the negative x. So basically we are going to have something like this, right? So from here, we say that y prime is equal to y times minus 2 times the ln 10, right? Minus 2 ln 10 all over 1 plus x all squared, right? Good. So this y was given in the question, right, as 10 power 1 minus x over 1 plus x. So we say that, but y is equal to 1 minus x all over 1 plus x, right? Right? So we put it in there, and then we have y prime, the derivative of that function, as 10 power 1 minus x all over 1 plus x times minus 2 ln 10 all over 1 plus x all over 1 plus x. So basically the differential of this function is given as this. All right, it's very simple. You just have to be good in the quotient, how to use the quotient rule, and you are good to go, right? Don't be bothered about this constant. This ln 10 is a constant, all right? So this, when you punch on your calculator, it will be give you 2 point something something. So whatever you have, you multiply by this. So that's why we maintain it there, right? So this is our final answer. Now, let's look at another problem. Let's look at another problem. Let's look at another problem. Our next problem is we want to differentiate y equals e power x cosec into bx plus c, right? We want to differentiate y equals e power ax cosec into bx plus c, all right? So now, how do we differentiate this function? How do we differentiate this function? We know that this function is going to obey the rule of the product, all right? We are going to use the rule of product, the product rule, all right? So now, because this is an exponential function and this is another linear function, which is the cosec, all right? Coming together, they are multiplying. And the product rule says if two functions are multiplying, what we do is that we differentiate the first function, we maintain the second function, right? And then we plus the differential of the second function, then we maintain the first function, all right? So now, let's go. Y prime, which is the differential sign, is equal to the differential of, let's maintain the second function first, cxc into bx plus c times the differential of the first function, which is e power ax, right? So that is what we have there. And then plus, we maintain the first function, which is the e power ax, right? So we maintain e power ax. Then we differentiate the second function, which is the cosec into bx plus c, right? So now, let's go ahead with our differentiation. So now we have been able to use the product rule correctly. So now let's move on. cxc cosec into bx plus c, then the differential of e power ax will give us a. We differentiate the exponent, which is ax, and that will give us a times the exponential function, which is e power ax, all right, plus the second function. The first function is maintained, so we have a e power ax, right? And then we differentiate cosec into bx plus c, all right? We differentiate cosec into bx plus c. And that is also equal to, when we differentiate cosec into bx plus c, that is also minus cosec into bx plus c times cot times bx plus c times b, right? Times b. So this in the brackets, all right? So we have y prime is equal to this. When you bring the a here, we have a cosec into bx plus c e power ax, right? And then plus a because of this negative, let me bring the negative here first. All right, so that we have negative b e power ax, right? Negative b e power as cosec into bx plus c cot into bx plus c, right? Good. So now let's continue from here. So the differential of the function, which is the y prime, is equal to e power ax cosec into bx plus c, right? Bx plus c multiplying, we are factoring e power ax cosec into bx plus c out, right? And then we have a minus b cot into bx plus c into bx plus c into bx plus c. All right, and this will finally yield so this will be our solution for this particular question. All right, bx plus c into a minus b cot into bx plus c. All right, so this is the solution to the differential of this e power ax cosec into bx plus c. All right, first you know that this is going to be done by the help of the product rule. All right, so now the product rule says maintain the second function, differentiate the first function. All right, plus maintain the first function and differentiate the second function. All right, and you know that when you differentiate e power ax, you have a e power ax. All right, then you write the second function plus when you differentiate, you maintain the first function. All right, so you have e, the second term, you maintain the first function, so you have e power ax, right, times differential of cosec into bx plus c. So you know that when you are differentiating such function, you differentiate the function. All right, and when you differentiate cosec into bx plus c, you have cot bs plus c, right? Cot negative cot cosec bs plus c, right? And then you maintain the function inside, right? Then you differentiate the inside function, right? When you differentiate this inside function, which is bs plus c, you have b. So that is what we have there, right? So then you simplify your function and then you move on from there. This will be our final answer to this particular question. All right, let's look at the third question. So the third question is we want to differentiate e power 2x cos x all over s sine x. All right, so this, you know that we are going to apply the quotient rule, and then we will also apply the product rule within this function, because we have two functions at the top, we have two functions below. All right, and then this is dividing this function. So the product rule also says that when a function is multiplying a function, you use the product rule. And the quotient rule also says that when you have a function dividing another function, you use that rule, the quotient rule. So now we are going to apply two different rules on this part. So let's go. So first, let's use the quotient rule, right? So first, let's use the quotient rule. So using the quotient rule says that you maintain the second function and then you differentiate the first function, right? So we are maintaining the second function, which is the x sine x, right? Then we differentiate the first function with respect to x, right? Cos x. Then minus, we differentiate the second function, right? And then we maintain the first function. So we have e power 2x cos x. Then we differentiate the second function, which is x sine x, right? And then we divide the whole of it by the second function, right? So we have x sine x all squared, right? So now this is going to be equal to x sine x, right, times, you know that this is exhibiting product rule. These are two functions, right? And you want to differentiate, so we have to apply the product rule in here, right? So applying the product rule also says that when you have two functions and they are multiplying, you have to differentiate the first function, maintain the second function, and then plus you differentiate the second function, then you maintain the first function, right? So let's go. So from here we differentiate the first function, and that is going to be 2 e power 2x. Then we maintain the second function, which is the cos x, plus we maintain the first function, which is the e power 2x. Then we differentiate cos x, and when you differentiate cos x, we are going to have sine x. We are going to have sine x, right? Minus now we are coming to this part of the term, e power 2x cos x into, now we are going to use product rule on this one as well. So the product rule says we differentiate the first function and then maintain the second function. Then the first function over here is x, right? So differential of x is also 1, right? Then you maintain the function, the second function, which is sine x, right? Plus the differential of the second function, and you know that when you differentiate the second function, which is the sine x, you have cos x, right? Then you maintain the first function over there, right? So that's what we have. Good. So from here, you know that this is all divided by x sine x all squared, right? So we have y prime is equal to s sine s, and then, right, let's split let's split them to each of the items in the bracket, right? So now this is going to be 2x sine x cos x e power 2x, right? And then this times this, that is also plus x sine squared x, right? E power 2x. Good. Then minus this times this will also be sine x cos x e power 2x minus x cos x cos squared x, because we have cos and cos, right? Cos squared x e power 2x. Good. So from here, all divided by sine x all squared, right? So from here we can see some common terms, this and this and this and this, right? They are exhibiting some identity in trigonometry. All right, so from here we say that y prime is equal to e power 2x cos x sine x, right, into bracket 2x minus 1. This is this exhibiting the same characteristics as this, right? We have sine x here, we have sine x cos x, and we have e power 2x here, e power 2x here as well. So we factor that out, and then we have 2x here, so that's what I have here, and then this will be minus 1, right? So minus, right, minus x e power 2x into bracket sine squared x plus cos squared x, right? Because we know that this sine squared x is here, sine squared x here, and cos squared x is also here. So when we do that, we are going to have cos squared x and sine squared inside, and that will be an identity, right? That is going to be an identity. So from here, all divided by s sine x all squared, right? And we know that but sine squared s plus cos squared s is equal to 1, right? We know that sine squared s plus cos squared s is equal to 1. So we have y prime is equal to e power 2x cos x sine x is into 2x minus 1 minus x e power 2x, right, into 1, because all this is giving us an identity which is equal to 1, right? All over x sine x all squared, right? So this is basically what we'll be having for this particular question. So therefore we can see that this is 1, and 1 multiplying this function will be the same thing, right? So we have this as our final answer. So having a function like this,